Let's be honest, the language of AI can feel like a totally confusing alphabet soup of jargon, right? Well, you're definitely not alone. Today, we're going to unscramble that soup and make it all make sense. Algorithms, transformers, hallucinations, vector embeddings. I mean, look at this. Right now, it probably just seems like a random mess of buzzwords. But what if I told you that when you put them in the right order, they actually tell a single incredible story? And that's exactly what we're about to do. We're going to take this jumble of terms and build this story of AI, piece by piece, so you can see exactly how it all fits together. So, where do we start? Well, you have to start with the foundation. We're going to tackle the biggest question first. How does an AI even begin to think in the first place? It all builds on itself, really, kind of like stacking blocks. It starts with algorithms. These are just the basic recipes, the core instructions. Then things get interesting. You get algorithms that can learn from data, all by themselves. That's machine learning. To make that happen, you organize them into neural networks, which are, loosely inspired by the human brain. And when you stack tons and tons of these layers on top of each other to solve really tricky problems, boom, that's deep learning. See, it's like a ladder, and each step gets you closer to what we think of as AI. Okay, so we've got the basic structure down, but how does it actually get smart? That brings us right to our next section, the learning process itself. The real engine behind all AI learning is this one process called optimization. The best way to think about it is like tuning an old radio. You're twisting that dial and you hear all this static, but you keep adjusting and the signal gets a little clearer and then a little clearer. That's what optimization is. The AI is constantly tweaking itself to find the very best answer, to find that perfectly clear signal in all the noise. So how does it actually go about learning? Well, there are two main ways to go about it. On one side, you've got reinforcement learning. This is exactly like training a pet. The AI tries something, and if it does a good job, you give it a reward. It learns by trial and error. But on the other side, you have something totally different, unsupervised learning. This is where you just dump a gigantic pile of data in front of the AI and say, go figure it out. There are no hints, no labels. It has to find all the hidden patterns completely on its own. And just to put a name on one of these methods, a really popular technique in that reinforcement learning camp is called Q-learning. It's basically a specific way for the AI to figure out the best moves to make to get the most rewards in the long run. So you take the foundation, you add in these clever learning processes, and then you scale it all up, way up. What do you get? Well, you get today's AI giants. The AI world we live in now is really dominated by a few key players. It all starts with foundation models. These are just enormous models trained on insane amounts of data that act as a base for almost everything else. Now, a special kind of foundation model that's fine-tuned just for text is what we call a large language model, or an LLM. And when you use these powerful models to create brand new stuff, like text or images or code, that's generative AI. So what was the magic ingredient that made all this possible? It was a revolutionary new architecture called the transformer. See, older models tried to read a sentence one word at a time, but a transformer, it looks at the entire sentence all at once. This lets it figure out the deep context, weighing how important every single word is to every other word. That's the secret sauce. That's why its answers feel so incredibly coherent and human-led. All right, we've seen the big, impressive models. Now it's time to get our hands a little dirty. Let's pop the hood and take a look at the real nuts and bolts that make this whole thing run. The very first thing you need to understand is the absolutely staggering amount of compute, that's processing power, that these things require. I mean, just look at this chart. The jump from older AI to today's foundation models isn't just a small step up. It is a colossal exponential leap. This incredible hunger for power is what defines modern AI. And why do we keep feeding them more and more power? It's because of something called scaling laws. It was this amazing discovery that basically, if you just make everything bigger, more compute, more data, bigger models, you get predictably better AI. It's almost like a cheat code. And this reliable formula is what has fueled this whole AI explosion we're seeing. So how in the world does an AI actually store everything it learns? Well, it comes down to two key ideas. First, you have the weights. Think of these as millions, sometimes billions of tiny little dials that the AI tunes over and over again during training. That's its stored knowledge. And second, to make sense of the world, it uses something called vector embeddings. This is how it turns concepts, like words or ideas, into numbers, creating this giant mathematical map of ideas where similar things are grouped together. And behind all of this, there's some seriously heavy-duty math. There are entire scientific fields like knowledge representation dedicated to figuring out how to structure information so an AI can use it. And engineers use a whole toolkit of advanced math, let's just call them the B's, J's, Y's, and Z's of the AI world, to build and fine-tune these systems. The point is, underneath that simple chat box is just an incredible amount of deep mathematical engineering. Phew! Okay, we've gone from the basic building blocks all the way to the cutting edge. For this last section, let's zoom out and bring it all back to the most important part of the entire equation, us, the human connection. Anytime you type a request into an AI like ChatGPT, guess what? You're actually doing something called prompt engineering. It's this new kind of art and science of figuring out the perfect thing to say to get the best possible answer back. It turns out how you ask the question matters a lot. And that exact moment, the instant the AI takes your prompt and starts generating a response, that's called inference. Think of it as the live performance. It's when the model takes all of its training, all those weights and embeddings, and puts it into action to answer your new question. But this whole human-AI interaction isn't without some massive challenges. We have to deal with at least 3 really big questions. First, hallucinations, when the AI just confidently makes stuff up. Second, ethics and alignment. How do we make absolutely sure the AI's goals are lined up with our own? And finally, explainable AI. This is the huge challenge of trying to crack open that black box and understand why the AI made the decision it did. So there you have it, from the simple algorithms that kick this whole thing off, all the way to the complex, modern-day challenge of explainable AI. Every single one of these terms connects. They aren't just random buzzwords, after all. They're the chapters in the single, incredible story of artificial intelligence. We've seen how all the pieces fit together. We've seen how this unbelievably powerful engine gets built. The only question left is the most important one of all. Now that we've built it, where are we as a society going to drive it?